All right, so our next problem is asking us to graph the quadratic function with the given information, then state domain and range, and our information is the vertex is 4, -2, and we have the point 0, 6. So I'm just going to start by graphing the information that it's giving me. And you're going to want to do this on regular graph paper. So I'm going to do it just freehand, but it will be a lot easier if you do it on nice graph paper, so that way your distances are a little bit more symmetrical. I'm trying to make mine evenly spaced. Okay, so if we start with the vertex, we're going to go, go down here. So we're going right 4 down 2. So 1, 2, 3, 4, down 2. Okay, so vertex is at 4, -2. And then my point is at 0, 6. So we're just going to go up 6. 1, 2, 3, 4, 5, 6. So here's my point at 0, 6. Now remember that our graph is symmetrical. So I should have this point as a mirror image on this side of it. So if I'm looking at this from my vertex point, and you don't need to put this on here, but just to kind of give you a visual of what's happening, we are counting up until we get to this spot. So really that's up, so 8 spaces. And then this way, if we count this distance, is going to be 4 spaces. So that means that I need to go another 4 spaces to put my next point, and then I can make that U shape. So if we're at 4, that means if I'm adding another 4 spaces, so again there has to be 4 on this side, we would be at 8, and then we still have to be at 6 for the Y. Okay, so 5, 6, 7, 8, and we're going up to 6 and adding our next point. Okay, so again, this point has to be at 8, 6 to keep our graph symmetrical. Okay, so this distance is also 4 away from where that vertex point would be. And then I would just connect them into the best U shape that I can make, or that you can make. And we've all seen my drawing skills. I'm not ever going to be an art teacher. Okay, so that's pretty decent U. I missed my point a little bit, but that's why we want to use nice graph paper. It'll make it a little bit easier. Now, the other thing with quadratics is where our vertex point is sitting. So kind of how we decide what our range is going to be. So if our vertex is sitting at the bottom of our U shape, we're going to call that a minimum value. So that is the lowest value of our function. If your U shape is opening upside down, so if it's opening this way, so upside down, so I'll actually draw it here. So this is just a kind of a separate thing here. So if we draw it, opening up this direction, this point up here is going to be the biggest value, so we would call this a maximum. And again, if it's opening up, where our vertex is sitting, that's a minimum. And we care about the Y value at that. So whenever we're talking about the min or max value, we're talking about whatever the K value of our vertex is. Okay, so again, the maximum value is when our graph opens upside down, and then the minimum is when it opens up, and it's always the K value of the vertex. So to do some examples. So it says determine if the function has a maximum or a minimum value, and then state the domain and range. So when we do this, we're just going to kind of think of a rough sketch of what our graph would look like. So if we look at number 6, there's a negative, so that tells us that our graph is going to open down like this. So our vertex is going to sit up here. So that means that we have a maximum. And then our domain has to be all real numbers. And then our range is going to be something, so Y is less than or equal to, and then whatever our K value is. So it's going to go from -infinity up to, and then whatever that K is. So again, to find that, that's the process of finding our vertex. So we have to start with H no matter what. So remember, our H is the opposite of B divided by 2 times A. So the opposite of the middle term, so this is going to be negative 2 over 2 times negative 1. So this will be negative 2 over negative 2, which will simplify to be positive 1 for the H. So now if we do f of 1, so we're just substituting 1 in for all of the x's, and then we're going to simplify. So 1 squared is 1, and then we have that negative in front, plus 2 plus 3. So negative 1 plus 2 is 1, plus 3 is 4. So that is our k value. So that means that our maximum value is 4, so the highest y value, and then our range is going to be from negative infinity to positive 4. All right, so if we do one more example, so again, we want to know if it's going to be a max or a minimum. So again, I'm just going to start with a rough sketch of the graph. So A is positive, so that means that our graph is going to be opening up like this. Okay. So again, that tells us that we're going to have a minimum value, and we'll need to figure out what that is here in a second. And then domain is still going to be all real numbers. And then our range, because it's opening up, we're going to have y greater than or equal to, and again, it's whatever our k value is. So that means that we're going to have whatever the k value of our vertex is all the way up to positive infinity for the range. So now we just have to do that. So to find that, we have to find the vertex. So again, to find the vertex, we are using h equals negative b over 2 times a. So we'll have a positive 24 divided by 2 times 4. So again, this is a, b, c. So 24 divided by 6 will be 4. And then to find the k value, we're evaluating at 4. So we're doing f of 4. So 4 times 4 squared minus 24 times 4 plus 11. Okay. So again, we're taking 4 squared first, which is 16. And then 16 times 4 will be 64. Minus, and then 24 times 4 is 96, and then plus 11. So now we're just combining those together. So 24 minus 96 is going to be negative 32, and then plus 11 will be negative 21. So that's our k value. So negative 21, and then again our minimum is negative 21. Yeah, that's hard to see. Negative 21. And that is going to conclude section 1.